fine. Okay, fine. Okay, so let me start this introduction to big data first of all. Okay, so we can say that what is the reason to go for big data? Simple. What is the reason to go for big data? Okay, so let me explain you. So what is the first thing? Before going for big data, okay, first of all, what is the reason to go for Hadoop? Okay, so nowadays we are listening about big data, some Hadoop, these technologies, right? So first of all, what is the reason to go for Hadoop? So why we are moving for Hadoop, and why every company they are moving for Hadoop as one of the solution? Okay, and what exactly? I mean, what is the problem they're facing? Okay, so generally, if you observe our companies, I mean software companies, okay, we are designing some web applications, right? We are designing some web applications. If you observe in our any software company, is everybody facing this problem, or audio is fine for everyone? Somebody ping me. Is everybody fine with audio? Hello? Hello? Audio breaks. So if who are not getting some audio disturbances, okay, I mean, if you are facing some audio inconvenience, so just try to relog in once again. Okay, you can relog in once again. So that it may fix the respective issue. Okay, just relog in those who are facing some audio issues. Okay, so we can wait for 2 to 3 minutes. So those who are facing the audio issues, so just try to relog in the session once again. Okay. So remaining students, just wait for 2 to 3 minutes. Okay. I hope now everybody's getting my voice clearly, right? Yes. Okay, fine. Okay, so here we're discussing about, first of all, what is the reason to go for Hadoop? Okay, what is the reason to go for Hadoop we're discussing. And generally, if you observe our software companies, so we are designing two types of applications. Okay, namely one is web application, and one more thing is standalone application. Means I mean desktop application. Okay, so we are not going to discuss about what is exactly standalone application or desktop application. We are focusing on web application. Okay, because 90% of the applications in which we are designing in our software, most of them are web application only. Okay, so what is web application? So most of you know. So let me define the definition. First of all, the application which is having client and server architecture, that type of applications, we are called as web application. Okay, so what is web application? First of all, the application which is having client server architecture, that type of applications we are calling as a web application. Okay, so let me explain you with some examples and with some architecture as well. So if you go with example, okay, so best thing is Google, Amazon. Okay, these websites simply we can they are calling as a client and server architecture. Okay, so most of the internet applications, what are the applications in which we are using? So that type of application, nothing but it. Simply we can call it as a web application. Now let me explain with some architecture as well, so that we can get some awareness. So this is some application which is having with some fields, some name which is one of the field. Okay, mobile number, email, password. So like this, I'm having some fields. Okay, and here we're having some save button. Here we are having a one more component, that is nothing but a database. So any RDBMS. Okay, it can be some MySQL or SQL Server. any RDBMS. Okay. So here, what is my requirement is, so here we're having some fields. So namely name, mobile number, email, and password. Once if I given the values for each and every field, and once if we click on the save, okay, these values it has to be saved to database. It can be Oracle, MySQL, any database it can be. So this is my requirement. So whenever if you if you want to design something in our software, what we are doing, so definitely your team lead or your manager is going to provide some requirement. Okay, this is my requirement in which you have to do it some within a 1 week or some 2 to 3 days. So here my requirement is just I need to design one web application which is having some fields, some 4 to 5 fields. And once if we click on this save button, so these values it has to save to database, right? This is my requirement what we have. So now we can choose any technology. So basically we are choosing some, most of the time we are choosing as a Java and .NET, .NET, PHP. So like this, we're having so many technologies for achieving this respective requirement. Okay. So just assume that I'm going with a Java as my technology. Okay. So now between this front end, so we can call this is a front end and this is nothing but a back end. Between this front end and back end, we are having a one more component. So that is nothing but a server. Between this front end and back end, we are having one more component called as a server. So it may be some Glassfish or Apache Tomcat or Logic. So like this. So now what is the process here? So just assume that I have given some values for each and every field. Once I click on the save, so this request will go to server. Server will communicate to database and some values is going to be stored. Okay, so just assume that some values, maybe some ABC, some mobile number, and abc@gmail.com, some password. Okay, like this, the values is going to be stored in any RDBMS software. Okay, and after storing these values, so just I want to display these values to again this front end. So again this response will go to server and server will server will get the response and this finally this response will be displayed to the front end. Okay, this is the general application, general overview. Nothing but it is not a complete architecture. Okay, so this is nothing but a simple architecture if you want to design any web applications here. So now if you observe any RDBMS software, okay, they are performing two tasks. So one is storage and one more thing is one is storage and one more thing is processing. So first of all here, what are the values in which we are getting from front end? These values compulsory has to store in database. Okay, then only we can process the respective values and finally we can display to front end. Okay, processing it has to be done by Oracle only. Just assume that I'm taking some Oracle database. Oracle need to store and finally that values, whatever the values it is in which it is already stored in RDBMS, it has to be processed. These are the major two tasks which is done by any database here, not only MySQL, any database. Okay, so till now clear all of you. So do you have any questions? Let me know. Fine. Okay. So now, what is the conclusion we have got it? Any RDB EMS software will perform two tasks. They are, one is storage and one more thing is processing. So these are the two tasks which is performed by any RDVMS software. Okay. So now here this is, it is our Oracle database. And assume that some data I'm storing. Okay, assume that 1 GB of data. 1 GB of data I'm storing here. Okay, so assume that it is at around some 2008. Okay, and here whenever if you observe, just best example is if you observe WhatsApp. Okay, so at exactly December 31st some 2017, so how many SMS or how many images or audio files, video files a single user will send here? So many. Okay, so on that respective day itself, so they will get some terabytes and petabytes of data, but finally they are storing and they are processing as well. So okay, so assume that here we're having some application. It may be some Axis Bank or some ICICI Bank, any application, any web application, simple. Okay, so they're getting some data, 1 GB at around 2008. Okay, and in 2009, so maybe they are getting some 10 GB of data in 2009. So like this, keep on there getting the data. So now assume that in 2018 they're getting some 100 GB of data in 2018. So can we store this 100 GB of data in Oracle means? So definitely we are not able to store, because what is the limitation? I mean, how much data a Oracle database can store? Maybe it can be some 12 GB, or just assume that 50 GB. That is a just limitation, just assume. Okay, 100 GB of data it was unable to store by any Oracle database. But immediately what they're doing, I mean, in real time what we are doing, so we are forming a concept. We are going with a concept called as cluster. So here cluster is nothing but a, just within a network we need to have a group of machines. So now what we are doing is we are taking some four to five Oracle instance. Okay, so it is one Oracle instance. So just assume that it is one Oracle and it is one more Oracle. It is one more Oracle. Just assume. And each and every instance is having a mutual connection. Let us assume that each Oracle instance it can handle some 20 GB of data. So total how much data it can store? Some 60 GB of data. Some 60 GB of data. Okay, but my requirement is 100 GB means we can go with some 5 to 6 instances. Okay, so now up to some level, so we can store the data. But beyond that, just assume that I'm getting some 1 terabyte of data means definitely I was unable to provide this solution. Means cluster also. So what is the current solution I'm having? So just I'm going with the cluster concept. But at some point of time, even I was unable to store this 1 terabyte of data in my clustering concept as well. Okay, so that is nothing but what exactly big data here. Okay, what is exactly big data? If any software was unable to store some data, or simply you can go with some example. So here I'm having some course, okay, some Excel data. So just assume that if you observe here 57.9 MB. Okay, so it can be opened by Excel. So same file, just I'm opening with some notepad. Just assume, see, so it was unable to open. If you observe my cursor, just it is loading only. It was unable to open. And at some point of time, we're going to get, so notepad was unable to process like that. Not exactly that error. Sometime it was unable to process. So it is keep on loading only. See here, I was unable to view, right? Just I'm canceling. Give me 1 minute. See, not responding. Status is not responding. Okay, wait. Same data, if I'm opening with some Excel, it will open very fast. See here, it is also taking time. But here, if you observe here, just I'm taking as a 57 point MB. For suppose if I taking some 100 MB. So definitely notepad was unable to process the data. So if you observe the notepad, so if I'm opening with notepad, it is taking some time to retrieve the data, right? But same thing, if I'm taking this 100 MB file, definitely notepad was unable to open the data. So now Excel is opening somewhat fast when compared to notepad. Means here, it depends upon the software. Okay, so how can you define this big data means? If you go for a here, if it is the best example, if you observe the particular thing, I mean if you observe this notepad or even this Excel, so this course data is nothing but somewhat big data for notepad. But if you make this data as a 100 MB, definitely it was a big data for notepad which was unable to open, nothing but we can say that processing. We are not able to achieve the processing from notepad. Okay, so even if you observe this 100 MB, so it is not a big data for Excel. It may be open definitely. Okay, so it depends upon the software simply. So there is nothing but a storage and processing. Okay, storage and processing. So here whatever the software, just as an Oracle or best example is Notepad or Excel. If you go for any software, okay, if you are storing or if you are processing in which we are not able to open or not able to process the data, that type of data is nothing but what exactly big data. Okay, so what is exactly big data here? Any amount of data that was unable to store or process by using existing traditional database systems can be termed as a big data. Okay, so let me mention a definition, simple definition. So what is big data here? What is big data? Any amount of data that was unable to store and process by using existing traditional database systems can be termed as big data. Okay, so what is exactly big data? Any amount of data that was unable to store and process by using existing traditional databases. Okay, that amount of data, what exactly we're calling as a big data here. So is it fine, all of you till now? doubts, let me know. Okay, fine. So we can define so many definitions for big data. This is a simple definition. Okay, what I had defined. So otherwise, I can define some more way within easy way as well. Big data is a word used for gathering of data sets that are large and complex, which is difficult to store and process by using existing database management systems, or we can say that traditional data processing applications, nothing but Oracle or MySQL like that. So that is nothing but what is exactly big data here. Okay, big data is a word used for gathering of data sets that are large and complex, which is difficult to store and process by using existing traditional data processing applications or tools. Okay, that type of data what we are exactly calling as in big data here. Okay, so here if you observe before coming to Hadoop, so if you observe in our software companies, so we are using this Oracle or MySQL as a storage device or database management tools, okay, for storing the data. Okay, so nowadays what is the problem is whatever the softwares which are using as a storage, it may be some Oracle or MySQL, so we are getting the data beyond their limitations. Just assume that MySQL can handle only 12 GB of data, but nowadays we're getting beyond 12 GB, which was unable to store by MySQL database or MySQL software. Okay, nothing but that data, it is a big data for MySQL, which was unable to store. So definitely it was not able to store means definitely it was unable to process the data as well. Okay, same for Oracle as well. So that is nothing but one of the problem what we're facing. So simply we can say that big data is a problem. Okay, big data is a problem and Hadoop is one of the solution. Hadoop is one of the solution to solve big data. Okay, Hadoop is one of the solution to solve the big data here. Okay, what is the final conclusion? Big data is a problem what we are facing, and Hadoop is one of the solution to solve the big data here. Okay, so can we store data less than 12 GB using Hadoop? Then why use RDBMS? Can we store data less than 12 GB using Hadoop? And then why use RDBMS? So here then why use RDBMS means exactly. So we are not going for Hadoop, okay, whenever we are not facing big data. Okay, so this 12 GB data we can store in Hadoop, but it is not the right solution. So if you're having some 12 GB or if you're having a GBs of data, so then you can go with Oracle or MySQL. Whenever if you're not able to store, for suppose just assume that we're getting some 1 terabyte, okay, or maybe some 500 GB. So definitely this type of data it was unable to store by any RDBMS softwares. Then we need to go for this what we call Hadoop is one of the solution. Okay, so definitely terabytes of data which was unable to handle by any RDBMS software. Then we need to go for this Hadoop is a solution for that. So is it fine, Amit? Still, if you're having questions, let me know. Okay. So anybody is having questions, let me know clearly. Okay, you can type in chat. I can respond. Okay, some of you ping here. But even smaller data set without any structure, can we use Hadoop? Smaller data set means so if you're having a smaller data, so then no need to go for Hadoop. You can go with our existing database management tools. So if you're having a smaller data, then Hadoop is not the good solution. Okay. Anything? So is it fine, Rakesh? Okay. So still, if you're having anybody questions, let me know. So I hope everybody is clear about what is exactly big data and what is the solution for that respect to big data. So that is the reason we're going for Hadoop. Simple. Okay. So types of big data. Okay, types of big data. Big data is widely classified or divided into three main types. They are so one is structured data, most of you know, and second thing is semi-structured data, and the other one is unstructured data. Okay, one is structured data, and one more thing is semi-structured data, and one more thing is unstructured data. Okay, so here, what are the data in which we are storing in Oracle or MySQL? So that data is nothing but a structured data, nothing but in the format of rows and columns. Most of you know. Okay, so let me define a structured data here. What is exactly structured data? The data that can be stored and processed in a fixed format is called as a structured data. Data stored in relational database management tools. So is one of the example of structured data. Okay, so the data that can be stored and processed in a fixed format is called as a structured data. That is nothing but rows and columns. Okay, so whatever the data in which you are storing in our database management tools, okay, that type of data simply we're calling as a structured data here. Okay, so now what is second one? Semi-structured data. So here semi-structured data best example is JSON. Okay, what is the best example for semi-structured data here? JSON. So I think most of you are aware of JSON. JSON data example or format. So see here. So it is a JSON data. Okay, this is nothing but a JSON data. This is the best example for semi-structured data here. Okay. So what is exactly semi-structured data? Semi-structured data is a type of data which does not have a formal structure of a data model. Okay, semi-structured data is a type of data which does not have a formal structure of a data model. Okay, so best example is JSON. Okay, JSON is a semi-structured data here. And what is the third one? Unstructured data. Okay, the data which have unknown form and can't be stored in database management tools is called as a unstructured data. Okay, so best example is most of you know audio, videos, images. Okay, this type of data nothing but a unstructured data here. But suppose here if you observe, so just I'm typing some Sachin Tendulkar. Okay, see here it is displaying some websites, okay, which is a just recognition as structure. Now if you observe here, this is a unstructured data, nothing but a video is unstructured, but still it is displaying. So now the main question to our software companies is, how can we process or how can we store this unstructured data? Because if you observe nowadays, right, internet is a big player. Okay, if you observe anywhere in within a mobile itself, we are having a for 3G, 4G networks. So we are generating a huge amount of data, which is a unstructured data. If you observe the WhatsApp, okay, instead of typing, just we are sending some voice message or some images, some audio files, video file. So much of unstructured data only we are sending to our any of our colleagues or friends. That is a major problem which we are getting this big data. Okay, basically we are having only structured data. Sometimes we're having a semi-structured data, but nowadays some 3 to 4 years or not a 3 to 4 years. So just we can say that around after 2010 onwards. So we're getting some unstructured data only, because nowadays we are sending audio files, video files, images, so that was unable to store and unable to process as well. So that type of data, what we are exactly calling as a I mean, not data here. There is nothing but what exactly calling as a big data. 90% of today's data is a unstructured data. Simple. 90% of data is nothing but a unstructured data here. And this is the best example for unstructured data. So just assume that we are storing some video in some Hadoop. Okay, so how can we retrieve this one, or how can we display it to front end? Okay, so that type of this is nothing but some simple use case. So where we can go for unstructured, I mean, which is the best example for unstructured data here. Okay, so sometimes even we can get some images. So if you observe, this is image. Okay, this is also nothing but unstructured data. But Google, they are storing and they are processing. So that type of data is nothing but what we are, I mean, we can call as unstructured data. Okay, so is it fine? Any doubts? You know, somebody ping video files in Hadoop. That is one of the question. So here, first of all, Hadoop is not for simply. Let me explain you. So if you observe Hadoop, so just I am answering your question. If you observe Hadoop, okay, so we are saying that Hadoop is one of the only big data problem, right? Now within the Hadoop, we are having. Okay, so here first of all, what is the big data problems which I have explained you? So big data problems. One is storage and second thing is processing, right? So we are saying that these are the two problems what you are facing from big data, and Hadoop is one of the solution. Now within the Hadoop, nothing but Hadoop is a, I mean, what is exactly Hadoop? What is the definition of Hadoop? I will define later. So here first of all, Hadoop is a framework, simple. So here we're having some Spring is a framework, .NET is a framework, right? These are the frameworks. So like that, Hadoop is a open source framework which is designed on Java. Hadoop tool itself is designed by using Java programming language. Okay, that is a next thing we're going to discuss. Here within the Hadoop, we're having a two components. One is HDFS and one more thing is MapReduce. Okay, within the Hadoop, what are the two components we're having? One is HDFS and one more thing is a MapReduce. And HDFS is going to solve the storage problem. HDFS is going to solve the storage problem, and MapReduce is going to solve the processing. Okay, so here storage is HDFS, and for processing we're going with MapReduce. Okay, so here not only MapReduce, here we're having some more tools within the Hadoop. Okay, so if you observe Hive, one of the processing tool, and Peak, one more tool. So like this, we're having so many tools. Okay, so we can say that Elasticsearch, so which we want to discuss, is one of the most popular logging tool. Okay, we're going to discuss later as well. So if you have here Hive and Peak, okay, or even MapReduce. So we are going to solve this one. Okay, so can we process image or video files in Hadoop means? Yes, we can do it by using MapReduce. We can go with what we call images or even some video files as well. Unstructured data we can going to process with MapReduce even by using Pig as well, not with Hive. Okay, I hope is the question is solved. Rakesh, is it fine? Still, if you're having any doubts, let me know. Rakesh, are you there? Okay, fine. So, anybody having doubts? Okay, so don't worry about what is this HDFS and MapReduce. We're going to discuss in depth later. Okay, but currently no need to worry. No audio at all. So, is everybody's getting my voice? So try to relog in once. I mean, most of the viewers they're getting the voice. Okay, they're fine with me. And so can you relog in once again? Divjot, Divjot. Sorry, Divjot. Can you relog in? Okay. Little bit voice coming again. So is it fine now? Okay. Okay, I hope it is fine. So no need to worry. So if you're not getting some concept, let me know so that I can explain you in number of ways. I mean, n number of not ways, n number of times. Okay, if you're not getting any single point as well. Okay, that is not a big deal. And okay, this question is solved now. And what is the second one? What is the thing we're discussing? Okay, so nothing but types of data we're discussing. Structured, semi-structured, and unstructured data. And we have defined the definitions, simple definitions, and as well as some examples as well. And even what we call with some use cases. Just some of you, what is Spark? Okay, what is Spark means? Let me explain you. This is a nice question as well. So just now I explained for processing we are going with the MapReduce, right? So just assume that HDF is nothing but a storage device, right? I mean, we are storing the data within the HDFS, right? Okay. So just assume that I am storing some 10 terabyte of data. How much amount of data here? 10 terabyte of data. Now I want to process this data by using MapReduce. Okay, so definitely I can achieve by using MapReduce, and it is displaying to the front end. I mean end user client. Okay, so now my data is, instead of 10, it may be some 100 terabyte. Can we process by using MapReduce means? Definitely we can process. That is not a big deal. Definitely we can able to process this 100 terabyte of data as well. But only one constraint is, so it will take time to process. Okay, so it will take time to process. Means, so here just assume that I have given some I have entered some search, okay, in some of the websites. So if you observe, it will show you some pop-up. Okay, so some button is going on, still it is processing. So why we get in this processing means it was not able to get the data immediately. Okay, it is not able to get the data within a fraction of seconds. Okay, so just assume that I am having some 100 terabyte of data in HDFS. I want to process this data by using MapReduce means it will take maybe some 2 to 3 minutes of time to retrieve the data and to display to the end user, I mean client. So 2 to 3 minutes means client will not wait. So client need to get the data within the fraction and milliseconds of time only. Even though if you're having some terabytes, petabytes, or even zettabytes of data, that is no need to worry by client. But whenever if he is accessing the application, he need to get the data within fraction of seconds. That is only requirement from client, irrespective of data, whatever the data we're having. Okay, so definitely if you're having some 1 petabyte of data, so we can able to process the MapReduce, but only constraint is it will take huge time to process. Okay, it will take huge amount of time to process that 1 petabyte of data. So it may take 10 minutes as well. Even we also don't know. Okay, minutes of time it will take. Okay, and finally it will definitely it will process, but it will take huge amount of time to process. Now if you want to solve this type of problem, I mean processing problems, right? So we need to go for Spark. We need to go for Spark, nothing but it is 100 times faster than MapReduce. Okay, simply we can say that Spark is a framework, or simply we can say it is a processing tool, which it is nothing but Spark is a processing tool faster than MapReduce. So is it fine? That's it. Okay, I hope it is fine. Mm, so are we covering Spark later in detail? No, here we're covering only Hadoop related course. Okay, so Hadoop content only covering, and even recently I'm using this Elasticsearch as well. It is one of the big data tool. So that thing also I'm covering within the Hadoop. So okay, okay. Spark is faster than Hadoop. Simple. Sorry, not Hadoop. MapReduce. Spark is going to improve the processing time. Simple. Okay. So is this free software to load? I mean, what is exactly free software means? Uh, I mean, Hadoop. Yes, Hadoop is a free software. Okay, we are going to discuss about in detail about installation. How can you install if you're getting some errors? So definitely we can solve within this session all these things. Okay, no issues on that. So here we're covering both installation part and as well as a practical part. I mean theory, installation, practical. These all these things we're covering. Will get a server for practice? No need, Jagdish. So you can install this Hadoop software within your system. That thing we can do it. Yes, free. Rakesh, Elastic is a part of Hadoop or a separate tool? So it is not a part of Hadoop. It is a big data tool. First of all. Okay, so big data is a problem. Big data, simply we can say that big data is having a so many tools, or we can say that big data ecosystems. Within big data ecosystems, so we're going to get Hadoop, HDFS, MapReduce, Hive, HBase, Scoop, Flume, Elasticsearch. These are the big data tools, simply, not big data ecosystems. Okay, is it fine, Rakesh? Uh, so many queries. Wait. Mm, can you please share the topics? So you can contact with admin, Suresh. Okay. Or how much Java background is needed for this course? So Java point of view, so we required some OOPs, collections, exception handling. So these three things is, I mean, these three concepts are sufficient to learn Hadoop. Okay, one is OOPs, and within the OOPs, so just we need to know class, interface, abstract class, okay, method overriding, overloading. So these concepts are sufficient, okay, and even what we call exception handling and collections. Okay, these are the concepts we require. So no need to worry about this Java. So Java again I'm going to cover from my end. Okay, before we are discussing a MapReduce, so we are going to cover the prerequisites for MapReduce. I mean Java I'm going to cover. So that thing you no need to worry. Uh, so yes, you can contact with admin for course content. Okay. Uh, I hope I cover all the queries. Is it yes, all of you? So still any queries? Fine. So what is the query, Amit? Still Spark if you want. So definitely I will cover. Okay, that is not a big deal. So it is 35 to 40 days. Okay, daily we are taking some 1.5 hour to 2 hour sessions. You can take that, it will take 40 to 45 days. Okay. So initially demo sessions will take some 1 to 1.5 hour. So slowly we can take it as a 1.5 hour session. Okay. Spark we're going to cover. Okay, a little bit Spark we're going to cover Suresh. Okay, some use cases or how can you retrieve the data. I mean, how can you process the data by using Spark? So these things we're going to cover. Simple, if you want. So timing 6 to 7:30. 6 to 7:30 a.m. It is according to IST. So I will start around 6:05 or 6:07 a.m. daily. Okay. Ask technically, okay, not these timings and these things. Ask if you are having some technical queries, let me know so that I can solve it. So any technical queries. So here we are covering the both installation part. Okay, so I mean installation theory and hands-on session we're covering each and everything. You don't need to worry about all these things. So within your systems itself, you're going to install this Hadoop software. Okay. So any questions or any queries? Okay. So just here I'm stopping on today only, okay, but tomorrow onwards I'm making that 6 to 7:30 a.m. So just I'm going to recap the session once again, and we will discuss some more concepts. What are the concepts we have covered today? So just I'm going to recap. I mean, just I will define once again these definitions of these things, and we're going to discuss about tomorrow this remaining part as well, and big data characteristics we're going to discuss. Okay, so there is nothing but five characteristics. One is volume, veracity, and value. Okay, these characteristics also we're discussing here. Volume, velocity, variety, veracity, and value. These are the five big data characteristics. So initially we're having only three ways. Now it is 5 ways. So these things we're going to cover. And if we're having it, tomorrow we're going to discuss about what is exactly Hadoop, or what is the Hadoop exactly, and just basic overview of Hadoop. And even if time permits, so we're going to discuss this installation part as well, hands-on installation part. So these things we're going to discuss on tomorrow. Okay. So I hope you have enjoyed the session. So if you're having any queries, we can discuss on tomorrow. And this remaining things you can check with this admin department. Okay. Thank you all of you.